All right, so your homework for this class, I am not a teacher to saturate you with homework, but I basically will spot check it. I will give it most days, um, but it's worth 10%. Your tests and quizzes are going to account for 70%, and your final exam will account for 20%. Okay, so that's basically makes up the whole class. Hopefully, if my math is correct, you get to see how good my math is because I will make errors. But that's how it goes. That doesn't mean, sweet, I don't have to do homework because it doesn't affect me that much. Don't become that person, because I have found in quite a few years of teaching, 26 now, this is my 26th year teaching, that if you're not practicing what you've been taught, unfortunately, you show me on your tests and quizzes that you're not having an understanding. That becomes obvious. A few things about me. I taught in Las Vegas, Nevada. My first few years teaching, I taught at a performing arts magnet school, which basically a magnet school was a way for the district to save money, because the district was saying, we're cutting programs from schools, and people were like, kind of like, wait, you're cutting a program? That's what my kid loves. Well, then they could apply to go to this magnet school and do what they preferred. So we were known for our music, whether it was orchestra or independent, like piano, guitar, or anything like that. We had chamber music. We also had dance. We had theater. We had art from a whole number of things, from painting to clay to even glass blowing. We had 8 different languages that were taught at our school. So if those were any of the things that you had to have, you would apply to go to Las Vegas Academy and go. Now, I want you to think about this. Clark County, which is Las Vegas, when I was there, had 55 high schools. So Las Vegas Academy would take the best actors, singers, actresses, musicians, artists, people who are engaged in language from the entire district. So I taught a few people you might know. I taught Matthew Greg Gubler, who is Dr. Spencer Reed on Criminal Minds. He was in my pre-calc class when he was a sophomore. And that was my first year teaching. I also taught another kid. His name's Schaefer Smith, but you don't know the name Schaefer Smith. Hannah, who's Schaefer Smith? You don't remember? I meant nothing to you 2 years ago?
A long time ago.
Schaefer Smith is, well, take a look on your phone. Ask your phone who Schaefer Smith is. Go ahead and do it. You could talk into it. Ask Siri. It'll pull up pictures. Who is he? Schaefer Smith. He's not a researcher. What's that? Not research. Look, Schaefer Smith music. Neo. That's who I taught. You guys know Neo? I also taught a girl named, when I taught her, her name was Priscilla Crossland. She's now married to Coffee Anderson, who's a country western singer, but Priscilla Anderson was an unbelievable dancer, still is. She'd be on stage with Britney Spears, be on stage with Snoop Dogg, Rihanna, a whole bunch of other different things. Unbelievable dancer. She is actually the choreographer for the Dallas Cowboys cheerleaders. So there's I taught a kid named Mike Spadoni, who is the keyboard player for Sheryl Crow. I taught a kid named John Cornell, who is the bass player in a band called Neo. There's a whole number of others that are just gone on and really do some incredible things.
A band was called Neo?
No, the band is called Hugo. Hugo, sorry. Yeah, 4-letter words, it's floating around Stirrup's head. Hugo is the band. So, yeah. So it's just kind of fun. So because you had me, it means you're going to be famous. It's direct correlation, which is kind of cool. But that's what we have. Now, sometime in the next week or so, I need you to head over to the bookstore and buy this really huge, thick book. This is going to be weight you down. This is like that biology or chemistry book that, makes your car sag to the ground because it's so heavy. Yeah, it's a pretty easy book. Okay. Good content. Don't worry if you don't have it. I have plenty of copies that I will hand out to you. But if you go over to the bookstore and you buy it, it's $5. If you can't afford it, just ask your counselor, and it'll give you a coupon, in which you then go over the necessities, and you get the book on us. But I'll give you about the first week and a half worth. So other things about this class, which are pretty cool, every other Friday, no matter what the content is that we're teaching, so every other Friday, so not this coming Friday, but Friday after, I will do something called a real-life application of math. And it's not something that is a difficult thing, but it's something that will make you aware of, unfortunately, where math is used to either influence your decision or not. So, in 2 weeks, we are going to talk about, let's talk about why it's not a good idea to go to rent to own once you graduate from college and get your first apartment, and you decide, oh, for $26 to 31 cents a week, I can have this 55-inch really cool television. Okay? So, and this is just the first few pages out of the book. Came in yesterday and made some copies for y'all, which I hope is okay. Did I forget anybody? Because I didn't do it on purpose. Okay, so the real life, I think you'll enjoy the every other week real life situations because I will put sarcasm with it. If you had me before, you know what my biggest weakness in the world is. I have a bad sense of humor. I laugh when old people fall. I'm sorry. I actually laugh when anyone falls, so it's gotten me out of going to the mall with my wife, which is kind of cool. Because I watched a guy take a tumble down the escalator, and I sat there and pointed and laughed. She goes, "What if he got hurt?" And I was like, "It's even funnier." And she's like, "You're not coming to the mall with me anymore?" I'm like, yes. So let's play some math. Uh-oh, where'd you go? I just unplugged that. It shouldn't have gone away. Good. Shut up. All right. So let's kind of take a look at this, and this is some algebra review. Some of you are really good with this stuff. Some of you are like, dude, that's the stuff I hate. Well, hopefully I give you a little bit more comfort in it. The first couple things are difference of two squares. And this is where you take two perfect squares. So perfect squares would be like your numbers like 1, 4, 9, 16, 25, etc. Or if you took x squared, because x times x is x squared. So you're doing perfect squares. So difference of two squares breaks up pretty easily. So if you had something like this, you'd say, well, how do I break this into two things? I know I have alternating signs. I have a positive and negative. They're called conjugates of each other. X times x is x squared, and 8 times 8 is 64. And it factors simple like that. Okay? But there are some of those that get really crazy. And I don't want you to be scared of the math. I want you to realize that the math is a lot of times just a big puzzle. And I know it sounds goofy saying it's a puzzle, but the thing about mathematics is math is something that will allow your brain to develop a different cognitive skill ability to allow you to think at a higher level when problem solving everyday problems. You guys know the reasoning of duh? It's called inductive reasoning. I call it the reasoning of duh. This is how simple inductive reasoning is. You go over to the buffet. You still with me on this story? You're walking down, you're finding all kinds of fancy good stuff. And then you get to the area that has those fancy orange colored lights shining down on food. They're heat lamps. And usually on the top of one of those heat lamps, it says caution hot. What do? You touch it. You're like, oh, that is hot. Well, duh. It said caution hot. It says wet paint. What do? Touch it. Oh, it is wet paint. Dang it. We're trying to figure out where to wipe your finger off now. Okay. Roads. Icy roads. Well, we all figured that out the last couple days. Especially all the new people who moved here from other states that didn't know what ice was and snow. In the ditch, in the ditch, in the ditch. It's like, well, dude, the speed limit is not a suggestion. You actually have to do less than that. Yeah, but I got all four wheels that drive. Yeah, me too. All right, but let's go down to, let's just take a look at number 4. Number 4 is 6x squared minus x minus 2. This is a method of factoring that a lot of people don't feel comfortable with. I have my lead coefficient, my a value is a 6. I want to factor this. So the first thing I do when I take a look at this kind of a factoring problem is, do I have anything in common other than 1 on all 3 of my terms? You can factor a 2 out. Yeah, I can factor a 2 out of the 6 and a 2 out of the 2. You're right, but what about the middle term? Does 2 come out of that? No, so I can't do that. So there's not a greatest common factor up here. I got to tell you, there's a lot of different ways to factor. There's the diamond method, the box method, the dream method. There's actually a method called the Cherry Creek method, not named after Cherry Creek High School. It came out of New Jersey, right by Princeton University. They came up with a technique. But guess what this school loves to use? Hey, they called it the Cherry Creek method, therefore we should use it. Okay, you ready for this? I know some of you are really good at factoring, so just fathom along with me. Very first thing I want to do is I want to multiply these numbers together. Make sure you keep the sign. So what's negative 2 times 6? Anybody? Negative 12. So everyone's still with me on this adventure. So, friends, we know that when we multiply 2 numbers together, if our answer comes out to be negative, one of them has to be a negative answer. So I have a positive and I have a negative answer that we're going to deal with. I don't know quite what it is yet, but we're going to get there. So then, we're also going to look at this. We know that 1 times 12 is 12. We also know that 2 times 6 is 12. And we know that 3 times 4 is 12. Do you agree that by me multiplying those numbers together, I'm going to get to 12? And in fact, if one of them's positive and one of them's negative, multiplying those 2 sets of numbers together, 1 and 12, 2 and 6, 3 and 4, I'm going to get to a negative number. Does this make sense? So there's a negative 1 right there, right? We don't put the negative in front of the x because we're lazy. That's really the main reason we don't do it. Some people say, oh, we just want to clean it up. But having a lead coefficient of 1 is kind of strange sometimes to some people. But we have to realize which of these factors up here, the 1 and 12, or the 2 and 6, or the 3 and 4, if I were to add them together, would give me a negative 1. Well, would 1 and 12, if one's positive and one negative, add up to negative 1? Nope. If I add 2 and 6 together, if one's positive, one's negative, would we get to negative 1? No. Are 3 and 4 1 apart? So is there a way that we can use these two, that when I add them together, I get to negative 1? If so, which one has to be negative for me to add those together to get to negative 1? Yeah. So it's going to be positive 3 plus negative 4. That result here of that math would give me that negative 1. Okay? So that's kind of the first step. And again, if you haven't seen this method before, I know that some of the teachers use something they call it the 80-20 rule or the 90-10 rule. There's all kinds of different ways of going about it. But this method will work every time if it's factorable. So, now that we know it's factorable, we're going to take those and I'm going to rewrite them and put a big old space. Can everybody see the big old space up there? If not, I'll highlight it for you. You see the big old space there? I'm no longer going to have negative 1x. I'm going to have, in whatever order I want, I'm going to either have negative 4x and 3x, or I'm going to have positive 3x and negative 4x. Doesn't matter which way you do it. So I just go positive 3x minus 4x. Friends, if I combine those back together, do you agree with me that I get to negative x? Okay? Again, I could have put these in either order. I could have had negative 4x first. I could have had positive 3x second. It doesn't matter. And then we're going to do something called factor by grouping. So I'm going to look at those first two terms. What's the biggest number I can factor out of both 6 and 3, other than 1? 3. How many x's can I factor out of those two terms? Well, the first one is x squared, which is xx. The second one is just x, which is just x. So can I factor x squared out or just x? Just x. If I factor a 3x out of this, of 6x squared, 3 times what number gives me 6? If I factor an x out of xx, how many x's are left? Just a single x. If I factor a 3x out of positive 3x, if I take this entire 3x and pull it out front, what number do we have to have as a placeholder? 1. Okay, we're on our way. This sign here always comes straight down. The middle sign will come straight down. This means I'm going to be factoring a negative out. So I'm going to look at these here. What's the largest number I can factor out of 4 and 2? 2. Can I factor an x out of both of those terms? No. So if I factor a 2 out of, or a negative 2 out of negative 4x, I'm left with a positive 2. If I factor a negative 2 out of negative 2, I have to have a placeholder of 1. And by doing this, here's what the puzzle shows. I get the 2x plus 1 and the 2x plus 1. I factor those out. What do I have left behind? I have a 3x minus 2. You just write that in the next binomial. And that right there will guarantee anything that's factorable, factoring in that exact moment. Okay, don't worry, that's not the only time I'm going to show it. And don't panic if you're sitting there going, oh man, I suck at this stuff. This whole class is not about factoring. Okay, there's a lot more to this class. Don't panic if you see that. But that's just one way of knowing how to factor. Will you do me a favor? Take a look at that very front page. Is there anything on 1 through 15, other than number 4, which we just did, that you would need help on? Anything on there? Give me an honest look. Yes, ma'am.
Either 13 and 14.
All right, I'm going to come look at your paper. Is that okay? 13. Okay, so 24x to the 4th, y, plus 30x squared, y squared. These are not like terms because we have different exponents on the letters, so I can't just go and combine these together to get 54. Okay, that doesn't work. So what we have to do is we can do it a number of ways. Now, sometimes we'll take the slower approach on some of these, so you start seeing a foundation to it. Some of you might see a little bit faster than others. It doesn't mean that if the others aren't seeing it, there's something wrong with you. But let's take a look real quick at just our numbers. What is the largest number that I could take out of both 24 and 30? 6? Does that seem okay? 6 times 4 is 24. 6 times 5 is 30. I think that's okay. Then I have to realize x to the fourth is this. And x squared is this. So what's the maximum number of x's I could factor out of the two terms? Can I take xx out? Okay. And then y is just that, and then y squared is yy. What's the most y's I could take out? Y or yy? Y. Okay, and again, I'm trying to do it on a basic level. So if I factor a 6 out of 24, what number's left? 4. If I factor an xx out of xxxx, how many x's are left? 2. If I factor a y from y, well, I need a placeholder of 1 if everything factors out, but not everything factored out, so I don't have to worry about it anymore. Keep the plus sign. If I factor 6 out of 30, what do I have left? 5. If I factor an xx out of xx, how many x's are left? None. If I factor a y out of yy, how many y's are left? What do you think? 1. Okay, problem is pretty much done. Just clean it up. 6 is fine. Make xx x squared. Keep y as y. Make 4 xx is x squared. This is our problem. So I tried to break it into the most basic part. Other ways you might have looked at this is you could look at 24 as 2 times 12, 12 is 2 times 6, 6 is 2 times 3, and then I have 30 is 3 times 10, 10 is 2 times 5, x, x, y, y, and you could have done it this way as well. You could have said, I could factor a 2 out and a 2 out. I could factor a 3 out and a 3 out. Then I can look at my letters. I have an x and an x, an x and an x. I have a y and a y. And so if the highlighted things come out, 2 times 3 is 6, x times x is x squared, y is by itself. What do I have left here? I have 2 times 2, which is 4, x times x, which is x squared, plus I have a 5, I have a y, and no matter which way we do it, we get the same result. Did that help you out? Cool. Anything else on 1 through 15 I can help you with? Yeah.
Check 15.
15?
I don't know if you can use it back for that.
I don't know. We will certainly find out. 15? Can I move off this one? We're good? 15. 3x squared plus 5x minus 4. Okay, we're going to go back to that first thing that we talked about. Okay, that's always going to be my go-to. First off, is there a greatest common factor other than 1 that I can factor out of all 3 terms? Nope, because I can't factor a 3 out of 5 or a 3 out of 4, so nothing's going to break up. Not everything has a letter, so I can't factor a letter out. So very first thing we're going to do is we are going to multiply this times this. So I get negative 12. Agree? And this will tell you if we can factor it. So I know that in order to get a negative 12, I have to have 1 positive, 1 negative. The factors of 12 are 1 and 12, 3 and 4, and 2 and 6. Are any of those numbers 5 away from each other? You know, I have a difference that, if I look at the difference between here, it's 11. Difference between here is 1. Difference between here is 4. I'm trying to get to that 5. So they call this, sometimes they call it prime. I accept anything, won't factor. Nope. Not this time. I'm not sure how many of those are actually mathematically sound, but in Stirrup's class, things fly that don't fly always in everyone else's class. Okay? So this one won't factor just because when I did this here, none of them were 5 away from each other. So it was impossible to factor. So you can just say any of those terms, or whatever you put, thumbs down, smiley face with a tongue sticking out, palm tree. Seem okay? All right, can I go to the flip side? And I am going to look at number 18. Okay? Number 18, we have x to the third minus 6x squared plus 11x minus 6. Okay? I have 4 terms. Agree? So the first way I want you to approach this type of problem is I want you to think about how we are doing the normal factoring. What's the most x's I can factor out of those 2 terms? 2 of them. So I get an x squared that comes out. That leaves me x minus 6. Still with me? This sign needs to come down here. Can I factor anything out of that other than 1? Nope, just 1. Okay, so we get stuck here. If this and this don't match, it won't factor by conventional means that we know of. Okay? Now, I'm going to ask you at some point to download the Desmos app, because I'll allow you to use the Desmos app on your phone. It's not photo math, understood? But the Desmos app, find it when you can. It's pretty easy. It's free. But I'm just going to go to desmos.com. It's a graphing situation. And I'm going to show you how we're going to be using technology to help us along with a lot of stuff. Okay, so we're working on number 18. So what I'm going to do is I'm going to go ahead and graph this. Now, this is, as it sits, not necessarily a graphing problem. Okay, I don't have y equals. But I'm going to cheat it a little bit. And I'm going to say that y equals x raised to the third minus 6x squared plus 11x minus 6. Okay? So the nice thing about Desmos, allows you to drag it around. I'm going to actually put it on the thicker mode. Makes it easier to see. So a few things we're going to look at. On Desmos, what is unique about those 3 points, friends? Which value is 0, the x or the y? Y? The x value is 0? Alphabetical, right? X comma y, x comma y, x comma y. So this means at 1 comma 0, it crosses the x-axis. At 2 comma 0, it crosses the x-axis. At 3 comma 0, it crosses the x-axis. Okay? So we want to factor this, and it says, hey, we want to factor with synthetic division. So we have 3 different x values. You still with me on this? Which one do you want to use? 1, 2, or 3? Pick. 2. All right, we'll use 2. Sound good? Can I use 2? Just trying to pick it arbitrary. Okay. So you were using 2. So I used this to tell me basically the roots. So you said, we're going to go ahead and use 2 to use synthetic division. Have you ever used synthetic division before? If not, this is a pretty valuable tool. Synthetic division is kind of a demented thing. Hey! You brand new?
Yeah.
What's your name?
Stacy.
Mr. Stirrup. You can just call me Stirrup. Let's see. And my friend, any seat that no one's sitting at or something that's not sitting at is open, including the 3 very comfy chairs up front. No big cursors on that. And I'm sorry, you said your first name is? Grayson. Oh, did you just enroll in this class?
Yeah.
Oh, okay, cool. That's a good seat for you. I'll give you one of these. We've just been going through this. And we'll get you caught up. And we're actually on the back side of the front page, looking at number 18. Okay, so synthetic division works this way. So one, I used Desmos to figure out where across the x-axis. I don't want to use synthetic division when it's a fraction. It's not as friendly. So you want to find a nice whole numbers. So a number comma 0, that'll tell you where across. We chose 2. We had a choice of 1, 2, and 3 if we went back to Desmos and looked at it. But this is what we're going to do. I realize there's a 1 here. So I'm going to put a 1 here. I have x to the third. I have x to the second, so I'm going to do a -6. I have x to the first power, so I have a positive 11. And I have the constant of 6. Still with me on this? We chose the 2 because it was one of the places across the x-axis when we looked at Desmos. Okay? Remember, that was what the picture looked like. We just picked 2, so it sounded good. All right. Synthetic division is a stranger version of math because it's like you're kind of making stuff up. Well, it's a tool that works. So first thing you do with synthetic division is the very first number you bring down front. Still with me? Now, if I go 1 times 2, I go 1 times 2, I get 2. -6 added to 2 is how much? -6 added to 2 is how much? -4. -4 times 2 is how much? -4 times 2 is how much? -8. If I go 11 minus 8, I get 3. 3 times 2 is? And I get a 0 here. Okay? By that becoming a 0, that verifies that it is one of the roots. It's one of the locations that crosses the x-axis. Okay? So that means that if I know that x is equal to 2, because I got a 0 right there, if I make this a binomial, I'm going to get x minus 2. Okay, how do I do that? I subtract the 2 from both sides. Okay? So that's my first answer. Okay? So we use synthetic division. It verified us one of the roots. What were one of the other 2 roots that we saw? 1 and 3? Which one you want? Pick. 3? Picking 3. So I'm going to use 3, but I'm not going to go with the original. I'm going to go with this. I'm not going to worry about the 0. Okay? And this is a newer concept for a lot of you. I know that. First thing I'm going to do, I'm going to bring the 1 straight down. 1 times 3 is? 3, right? -4 added to 3 is? Something costs $4. You have $3 in your pocket. How much you owe? Anybody? -4 plus 3. It's -1. -1 times 3 is? -3. 3 added to -3 is? 0. Because they got that 0 there, that means that x is equal to 3. So if x is equal to 3, the binomial it goes with is? Subtract 3 from both sides. Bring it back over. This is my second binomial. Okay? Hey, what was my last factor? 1? So 1 was my last factor when we looked at our graph, right? So I'm going to just synthetically divide by 1. I'm going to use these values now to synthetically divide. Remember, the 1 comes straight down. 1 times 1 is? -1 plus 1 is? That means that x is equal to 1. So that's going to be x minus 1. And that's my third answer. Okay, so my answer factored out is x minus 2, x minus 3, x minus 1. Hey, friends. What time are we out of here? 6? All right. Do me a favor. Try at least 6 of these. Try at least 6 on that page. Not including the ones I did. Deal? Front and the back. 1 through 19. So it's the front page, 1 through 19. You just pick 6 of them. Not 6 I tried. Just try them. Have a great day, friends. Take care of one another. Yep.